Now we learn about subspace, which is I have right here the definition of subspace, and you can see the definition of subspace is a set of W of factor Rn. Here is the factor with the n tuples, and it's called a subspace of Rn if it's only following the three properties. What of the properties are? The first properties is the zero factor belong to W, so it means that it cannot be the zero belong to zero factor, so it have to minimum have a zero factor as a member to that belong to W. And the second one is closed under factor addition, or we can say that U plus V, it have to belong to W, or whenever U and V belong to W, then U plus V belong to W. So if you have U and V value, it is belong to W, so this operation will be belong to W. It's called as a closed under factor addition. And the third one is closed under scalar multiplication. So if we have any factor of U and we multiplied it with the any scalar numbers U, it have to belong to W. If you can hold all of the properties or axioms of subspace, we can say that this is the subspace of Rn. Okay, we will show you the exercise to help understand on this case. Okay, for the first, if you have this exercise, we show that the set of here is number of W1, W2 and W3, where the R is 6, W1 minus 5, W2 plus 4, W3, it has to be 0. Then it has to be 0, and it's the close bracket is a subspace of R3 because we have 3 unit factor here. So is this condition is hold all of the properties of subspace, so we're gonna prove this one. Okay, for the first, since it had to be 0, so we can including the input the 0 number of this one. So if we want the result is 0, so we have to include 0 minus 5 of 0 and plus 4 0, so it will be 0, and the component of 0, so it holds the first property because at least we have to have 0 factor, so we will have 0 0 0 factor here. Okay, we go to the second properties. Let U in this case, we can say that remember the second here is U plus V, so is this the addition, we can say U1, U2 or U3. Okay, and don't forget we have to add the V factor, is V1, V2 or V3. Okay, and then it have to be in W, and if it be in W, so we can say that it is the subspace of R3. So we can prove that we input this number to this equation, so we can write for the U, it is for the U, it will be 6 U1 minus 5 U2 plus 4 U3 will be 0, and for the V it is 6 v1 minus 5 v2 plus 4 v3, it will be 0. Okay, I have to move a bit. Okay, then we can write it here 6. It's the same, right? So we can add this one plus u1 plus v1 minus 5 u2 plus v2 plus 4, this bracket, u3 plus v3, it will be 0. Why we can write this one like this? Because actually from here we can okay, we can write here actually like this one, u1 plus v1, u2 plus v2, u3 plus v3. So after we get this, we can add that 6 u1 minus 5 u2 plus 4 u3 plus 6 v1 minus 5 v2 plus 4 u3. Yeah, we have this, all of unit number is have to be 0, so it will be 0 plus 0, so the result is 0. Okay, then we move to the third property. For the third property, so you can tell this one. For the second property, the third one property, it is the scalar multiplication. Scalar multiplication closely. So this number 3, you can say that let u, it will be u1, u2, or u3. Then we have this, it will be in W for any scalar, or we can say that scalar is C. So then we have a CU for the scalar, and it's same with C, U1, U2, U3, and it will be C1, CU2, and CU3. So after we have this one, remember that we can write this 6 C1 minus 5 CU2 plus 4 CU3. Okay, and it will be C here. The result is 0. So what is the conclusion? The conclusion, because the CU is also satisfied, the equation is satisfied, the equation, so it's called the third scalar multiplication. So it goes under scalar multiplication, and it will be concluded that the W is the subspace of R3. Then we will continue to the next exercise. Okay, the next exercise is so almost the same, but it only to answer you to more understand for this topic. We have that show that W equal to ABC here, which the condition is like this one: A equal to B is the subspace of 3, where this is the real number. So it is a subspace of R3. We're gonna prove this. Okay, we can see that the we have here ABC because it has been determined first, so we cannot say that it is W1, W2 or W3. It is ABC, so we can write with or W is not 0 factor, because you see that A, B and C is 0, so we have 3 member here, 0.0.0. Okay, and second one, is it close to any addition? We can take any U and V. Just have to be U plus V are the number of R3, and we will take the U is A1, B1 and C1. Then the V is A2, B2 and C2. Okay, and then it have to be the belong to what's that? They belong to W. So also it's belong to W. And then we have the condition terms here that A have to be to B. So it's mean that if we have A1 here, it will be 2B1, and A2 will be 2B2. So based on this one, we can say that A plus A, or A1 plus A2 will be equal to 2B1 plus 2B2, or we can write this 2B1 plus B2, and it will show you that it is A, it is 2, and it is B. So U plus V is belong to W because it fulfills this term. Okay, and the third one we'll write here. The third one is the multiplication cursor. We can take any U, but it's the most important, have to belong to W, and you can choose of U here is A1, B1 and C1. Okay, or because we don't have other, we can only write here as ABC, ABC, because we don't have any V factor here, it's only U factor. So we can add this one with any scalar. We can say the scalar is, the scalar is alpha. So how if we multiply any scalar to the U factor, we will have this one. So alpha is A, B, C, or it will be alpha R, alpha B, and alpha times C. And if we take only alpha R, so it will be, because we have the A is equal to B, so we can write this as alpha to B, or we can write this 2 alpha B, or whatever. But if we do this operation, so we will get A, that's 2B. It holds all of 3 properties. It holds the 3 properties. So the second exercise also is a subspace of R3. Okay, thank you.